So if you're using Terraform, you're dealing with a state file, whether you realize it or not. And how you handle that one little file, well, that's pretty much the dividing line between just messing around with automation and building professional, rock-solid infrastructure as code. In this explainer, we're going to break down exactly what the state file is, why it matters so much, and how to manage it like an absolute pro.
So let me just ask you something straight up. Is your team's infrastructure a ticking time bomb? I mean, if you've got more than one person running Terraform Apply from their own laptop, the answer is probably yes. You might be just one command away from a corrupted state, duplicate resources, or a really bad day at work.
Okay, let's break this down. When you're the lone wolf, just starting out, learning Terraform on your own, the default local state file works just fine. It's simple, no big deal. But the second you join the team, that exact same setup becomes a huge liability. When you have multiple people, each with their own separate state file, it's a recipe for disaster. It's like everyone is trying to build a house using a different version of the blueprint. It just doesn't work.
So here's our game plan. We're going to start with the local state trap. Then we'll cover the solution, remote state. After that, I'm going to walk you through a hands-on S3 backend setup. We'll wrap up by talking about mastering state management and, most importantly, how all of this ties directly into your career and crushing those technical interviews.
All right, let's dive into our first section, the local state trap. We really need to understand why Terraform's default setting, which is so convenient when you're learning, is actually pretty dangerous in a real professional environment where you're working with other people. First things first, what is the state file anyway? Well, every time you run Terraform Apply, Terraform creates this JSON file called terraform.tfstate. You can think of this file as Terraform's brain, its memory. It is the single source of truth that maps every resource you defined in your code to the actual real-world resource running out there in the cloud.
And here's where that file becomes a superpower. It lets Terraform do something called drift detection. So imagine someone on your team logs into the AWS console and manually changes a setting on a server. The next time you run Terraform plan, Terraform will look at its state file, compare it to reality, and immediately tell you, hey, something's different. It's an incredible safety net for your infrastructure.
This brings us to the million-dollar question. What actually happens when two different engineers, both with good intentions, working on the same project, run Terraform Apply from their own machines at about the same time? Remember, they each have their own local terraform.tfstate file, and neither has a clue what the other one is up to.
The result? It's chaos, pure chaos. Since their state files aren't in sync, they might both try to create the exact same resource, causing errors and conflicts. Or even worse, one person might destroy a resource the other person just created, simply because their local file said it shouldn't exist. This is exactly how production outages are born. So if local state is the problem, what's the solution? Well, that brings us to our next section, remote state. It's all about creating one single source of truth that the entire team can trust and rely on. You know, the best way to think about this is with a simple analogy. Using local state on a team is like everyone trying to co-author a report by emailing separate Word documents back and forth. It's a mess. You never know who has the latest version. Remote state, on the other hand, is like switching to a single shared Google Doc. Everybody sees the same thing, in real time. It just works. But just having that shared file isn't quite enough. We also need something called state locking. This is an absolutely critical safety feature that comes with remote state. It basically acts like a traffic cop, making sure that only one person's Terraform Apply can run at a time. This completely stops those dangerous collisions we talked about. So how does this locking thing work in practice? It's actually super simple. Engineer 1 runs Apply and immediately gets the lock. A few seconds later, Engineer 2 tries to run Apply too, but instead of causing chaos, their terminal just waits. It'll say something like, state is locked by Engineer 1. As soon as Engineer 1's run is finished, the lock is released, and Engineer 2's run automatically kicks off. It's safe, orderly, and predictable. Okay, that's enough theory. Let's get our hands dirty. For Section 3, we're diving into a practical, hands-on guide to setting up a remote state backend using AWS S3 and DynamoDB. This little block of code right here is where the magic happens. You add this Terraform block to your configuration. The backend S3 part tells Terraform, hey, from now on, store the state file in this S3 bucket. You specify the bucket name,
the region, and a key, which is just the file path. Now, the really important part is that DynamoDB table line. See, S3 itself doesn't do locking, so we use a DynamoDB table to handle that for us. This is the gold standard production-ready setup for AWS.
So what's the actual process to switch from local to remote? You're going to love this. It's basically 2 steps. First, you add that backend block to your code. Second, and this is the really cool part, you just run Terraform init. Terraform is smart. It sees that new backend configuration and it'll actually ask you, hey, I see you have a local state file. Do you want to copy it to the new S3 backend? You just type yes and boom. Terraform handles the entire migration for you. It's that easy.
Now, setting up the backend is just step 1. To really master Terraform, you need to build some professional habits. So let's jump into Section 4, Mastering State Management, where we'll cover the biggest mistakes people make and the best practices you absolutely need to follow.
These are the rookie mistakes we see over and over again. Number 1, obviously, is still using local state on a team. A close second is setting up a remote backend but forgetting to enable locking. But the next 2 are huge. Never, and I mean never, commit your state file to Git. And always be careful about hard-coding sensitive data like passwords because they can end up in your state file in plain text for anyone to see.
And this brings us to the golden rule. If you forget everything else, please remember this. Your state file is a treasure trove of sensitive information, credentials, private IPs, you name it. From day 1 of any new project, add terraform.tfstate and the .tfstate.d directory to your .gitignore file. It's a non-negotiable security practice.
So let's just boil it all down to 3 dead simple, unbreakable rules. 1, if more than one person is working on a project, always use remote state. 2, always enable state locking. And 3, never, ever, ever commit your state file to Git. You follow those 3 rules, and you're already way ahead of the game.
Okay, so why are we hammering on this so much? Is it just about being a good engineer? Yes, but it's more than that. This stuff is a massive signal of your professional skill level. So let's talk about your career and how knowing this inside and out will help you nail job interviews and pass certification exams.
If you're studying for the Terraform Associate certification, this is basically your cheat sheet. These topics are guaranteed to show up. The whole purpose of the state file, the difference between local and remote, how locking works, how to initialize a backend, and how to protect sensitive data in your state. The good news? We just covered every single one of them.
All right, picture this. You're in a technical interview for that dream DevOps job. The interviewer leans in and asks you this question. This isn't a trick question, it's a test. They want to know if you understand the single most fundamental problem of doing infrastructure as code with the team. So how do you answer?
We prevent corruption by implementing 2 key things. First, a centralized remote state backend, like AWS S3, which creates a single source of truth for the entire team. And second, mandatory state locking, using a service like DynamoDB to ensure that only one operation can change the infrastructure at a time. An answer like that shows you don't just know the commands, you understand reliability and safety.
And really, at the end of the day, that's what this is all about. Mastering Terraform state management isn't just a box to check. It is the absolute foundation for building reliable, professional infrastructure. It's what allows your team to move fast without breaking things. Get this right, and you unlock the real promise of infrastructure as code.